Delaware Tech, Chemistry 100, Chemistry 110, Unit 4 continued, Nomenclature of Polyatomic Ions. Polyatomic ions are ions that are composed of groups of atoms, frequently different kinds of atoms, that stay together because they're actually covalently bound, but we're not going to worry about that. They are usually part of ionic compounds, and polyatomic ions, they stay together and they carry an overall charge, either positive or negative. The vast majority of polyatomic ions are negative. There are a couple positively charged ones. So they'll end in either "ide," "ite," or "ate." Two of them that end in "ide." Now, I already told you "ide" is usually reserved for single atom anions. These are the two exceptions. Hydroxide, which is composed of oxygen and hydrogen, one of each, OH. Sometimes it's written OH, sometimes it's written HO, and it has a single minus charge on it. And cyanide, which is carbon and nitrogen bound together tightly with a negative charge. These are the only polyatomics that end in "ide" that you need to know about. All the others will end in "ite," I-T-E, or "ate," A-T-E. So we have nitrite and nitrate. And what you'll notice is whenever you see these pairs of "ite" and "ate," the "ite" will always have less oxygens and the "ate" will always have more. It does not tell you how many of each. It just tells you one is less and one is more in terms of the number of oxygens on it. So nitrite and nitrate are also all -1. So far I've only shown you -1 charged polyatomic ions. These are all polyatomic anions with a -1 charge. We also have acetate. This is a polyatomic ion composed of 2 carbons, 3 hydrogens, and 2 oxygens. And there are many ways this is written. Sometimes it's written as shown here. Sometimes it's written as a slightly different version of the second one. I'll show it right here as CH3COO minus. Sometimes in more advanced chemistry books, you'll see it written as acetate, just the letters AC, followed by an O and minus. And sometimes you'll just see it as AC with the minus. These all mean the same thing. I will not use these in class, but you will see these occasionally. So you should be familiar with those. And I will erase that. So acetate is a polyatomic ion that has a single negative charge on it. Permanganate, you'll notice it ends in 8. It has a lot of oxygens. It has 4, in fact. And the per means the most number of oxygens, and the 8 means it's got a lot of oxygens, and per comes from hyper, as in overloading. So this is a polyatomic ion that has a -1 charge, and you'll notice all of these are -1 so far. Chlorite and chlorate, so one has only 2 oxygens and one has 3 oxygens, chlorite and chlorate. But when we have 4 different versions, we name the one that has even more oxygens. We still say 8, as I just did with permanganate, and we say per in order to tell me it's even more than the regular chlorate. So this would be 1 here, 2 oxygens here, 3 oxygens here, and 4 oxygens for this one. But you'll notice the charge is exactly the same. They're all a -1 charge, no matter what they are. So and when it's less than the chlorite, we say hypo. Remember, hypo and hyper are opposites. Hyper means extra. Hypo means too few or lower. So it's the same root words that you might have learned in your medical terminology class if you took that. So we have all these different polyatomic ions, and you'll notice with the hypochlorite, the chlorite, the chlorate, the perchlorate, you can make a set of 4 for not just chlorine, but you can do it for bromine. So it would be hypobromite, bromite, bromate, and perbromate. And you can even do it for iodine. So it would be IO -1, IO2 -1, etc. And that would be hypoiodite, iodite, iodate, and periodate. So it's a little unusual pronunciation, but that would be the name, and you can do that with all 3 of these halogens. So I'll clear any notes we've got there. Okay, so these are the bulk of your negative 1s so far. Now we're going to look at the negative 2s. We have sulfite and sulfate, another pair, but you'll notice this itonate pair has 3 and 4 oxygens respectively. It's not the same number as with the nitrite and the nitrate. And that is because ite and ate have nothing to do with the actual number of oxygens. It's just the relative number. The one that has less is ite. The one that has more is ate. Chromate is CrO4 with 2 negative charges. And dichromate is a form of it where 2 of them have been linked together and 1 oxygen's lost. So you have Cr2O7. And it's called dichromate because it was synthesized from 2 chromates. So don't be confused by that. It's not telling you to make 2 chromates. It's telling you dichromate is a completely different polyatomic ion in its own right. But all 4 of these are -2 charge. Another one that's very common is carbonate. You might have heard of carbonate or carbonated beverages or sodium carbonate. These are molecules that involve a CO3 with 2 negative charges on it. So all of these are negative 2s shown here. Our negative 3s are phosphite and phosphate. You'll notice phosphite has 3 oxygens, phosphate has 4. Kind of the same way as sulfite and sulfate, but it's a -3 charges now. So it's very difficult to remember all of these right away. That's why you're going to get familiar with as many as you can, but always have that chart handy whenever you're doing nomenclature problems with polyatomic ions. At first, everybody struggles with memorizing these. Try to do the best you can, getting a few of them under your belt, but it's going to take time to learn all of them. Now, in addition to these main ones, we also have derivatives of some of the others that are shown here. If we take carbonate and add an H plus to it, well, that adds the H, and the plus charge takes away one of the minus charges. So hydrogen carbonate, HCO3, has a -1 charge, not a -2 charge. By the way, the other name for hydrogen carbonate is bicarbonate, which I am sure most of you have heard that term for. This is the active ingredient in baking powder and baking soda for that matter. So bicarbonate is the old name for hydrogen carbonate. People are trying to stop using the bicarbonate because bi suggests 2, and the bi doesn't mean 2 in this case, which is confusing. It actually meant the addition of the hydrogen. So that throws people off a lot, but hydrogen carbonate and bicarbonate are the same thing. We can also add hydrogens to the phosphate. The phosphate has 3 negative charges, so we can add 1 hydrogen phosphate with only -2 charges. We've lost 1 charge. Or we can add 2 hydrogens to make dihydrogen phosphates, and now the name says 2 hydrogens added to phosphate. That takes away 2 of the negative charges to make a total of -1 charge. And finally, we have 2 positively charged polyatomic ions. Ammonium, which is made from ammonia. Ammonia is NH3, and I'm sure you've heard of that. Ammonia has a lone pair of electrons, and that can bind an H plus that might be from some acid. I know we haven't talked about that yet. But when you link these 2 together, you make ammonium. So ammonia becomes ammonium. The ium ending here means positively charged. And the last one here is hydronium ion, which we won't talk about so much here. It's not really involved in nomenclature much, but it will be involved when we talk about acids and bases. And just like ammonium was made from ammonia and an H plus, hydronium is made from water plus an H plus, a hydrogen ion. And oops, let's get rid of that. And when you add these together, you get H3O plus. That's hydronium ion. It is what's referred to as the conjugate acid of water. And we won't talk about that in this unit. That will be when we get to the acids and bases section. So let's look at the types of compounds you form. Well, polyatomic ions, by definition, have at least 2 different kinds of atoms in them. So that means when they're involved in ionic compounds, you have the cation, that's 1 element, and then you have a polyatomic that's at least 2 more. So you have at least 3 elements. 3-element compounds are called ternary ionic compounds. Remember, binary is 2, ternary is 3. So if you see that there are more than two different atoms in there, you know you have a polyatomic ion, and you look for those formulas. So it's the same rules as before. You're going to be naming the cation, and then you're naming the anion, except the anion is from that table of anions we just looked at. And you all have your own copies, so make sure you have them available. You're going to need your periodic table, and you're going to need your table of polyatomic ions whenever you're doing any of the ionic nomenclature problems. What I highly recommend is whenever you spot a polyatomic ion, for yourself, put a little note that's in parentheses, just so you can see it. If it's not already in parentheses, like it is here and here, just put it in parentheses so your mind can spot it and separate it. Because you're not naming anything in the polyatomic ion. In that first one, it's NO3. NO3 is from nitrate. Nitrate is NO3 with a minus charge. And the sodium ion is Na plus. And therefore, you just name the first ion, sodium, and you name the second ion, nitrate. So our answer is sodium nitrate. Just like before, you name the cation, then you name the anion. We look at number 2. Number 2 has a calcium ion. It's always +2, so we don't need to worry about that. And that's a sulfate ion. So it's just calcium sulfate. The next one we know has a copper, and we know it has nitrate. And now we have to think about it because we don't know the charge of the copper. We know the copper, there is one of them, and we know, and this is where you're going to put parentheses around it, we know the nitrate, there is only one. Now people will look at this and go, NO3, oh, there are 3 of them. No, 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 no. Put the parentheses around the whole polyatomic and forget the formula of the polyatomic. Only look to see how many polyatomics you have. You know you have one nitrate. It has a -1 charge, and therefore 1 times 1 is equal to 1 times what? And that we can see the X, the charge of the copper, must be a +1 charge. So we know it has copper +1 in it, and therefore this is copper 1, that's the name of the cation, nitrate, that's the name of the anion. If we look at the next one, it's composed of one of the positively charged polyatomic ions, ammonium. Ammonium is only one thing. It's NH4 plus. Don't worry that there are 2 of them. It only has one choice. It's ammonium and it's oxide. Ammonium oxide. Simple as that. Whereas the next one, we have iron and we have a polyatomic ion. We go back to our table, ClO2. ClO2 has a single negative charge, and it is chlorite. So we know that's a -1 charge. Put the -1 outside of the parentheses. Always put it outside the parentheses. You're really going to forget what's in here. It'll just confuse you. And you know you have 1 iron, so 3 times 1 is 1 times 3. And therefore you know your iron is +3, and your chlorite is always ClO2 minus. So you literally name it, iron 3, chlorite, and there's your name, iron 3 chlorite. And you're going to go through each of these the same way. Go ahead, practice them. Remember, you multiply whenever you have an anion, whether it's a polyatomic or not, it's going to have some number of atoms, and our cation is going to be over here. It's going to have some number of atoms. So let's say there's X of these, there's Y of these, and this has a -N charge, and this has a -M charge, a positive M charge. We know that this times this is the same as this times this, forgetting the negative signs. So we multiply these 2 together, and they must be equal to whatever these 2 are. And that will give you the formula for these. So go ahead, try the rest of these. I'm going to pause for a second. Okay, now I'm going to show you the answers. Magnesium chromate, there's no choice for magnesium. So when there's no choice, it's really easy. You name the first thing, you name the last thing. Strontium and acetate, strontium acetate. Now you have lead, and this is lead 4 nitrite. Aluminum is only 1 charge, +3, so it's aluminum perbromate. Bromate's not on your table, but it's just like perchlorate. CN is cyanide. You have 4 cyanides. Each one is a -1. Sorry, a -1. Therefore, you have a total of -4 charges. You must have +4 from the tin, so it's tin-4 cyanide. And that leaves us with the last one. It's chromium something phosphate. And we know that the phosphate is a -3 charge, and we only have 1 chromium here. So let's get rid of that. Keep that. Whoops, sorry. Let's go back into that. We have 1 chromium there, and that means that the chromium must be a +6 to match those negative charges. And I'll clear that out. It's not letting me clear. And now let's do the other way around. Now the other way around, we're starting with the formulas. I'm sorry, actually, we're doing more of the practice problems. So go ahead, try these on your own, but I recommend that whenever you're doing these, you're going to want to put parentheses every time you see a polyatomic. To help yourself, just put a parentheses around there. Sorry, that's not a highlighter. That's not a pen. That's a highlighter. So here you see a phosphite, a sulfate. Here's a dihydrogen phosphate. Be careful with that one. And now, every time you see a metal that's by itself, or a polyatomic by itself, just make sure you put 1 so you know how many of each you have. And now you're comparing 1 nickel with 1 phosphite, 1 cobalt with 1 phosphate, 1 silver with 1 dihydrogen phosphate, 1 tungsten with 2 sulfites, 1 aluminum with 3 permanganates, 1 rhenium with 7 hypochlorates, and then the rest of the numbers are there. And that will allow you to determine, you have to fill in the charges so you'll know that that's a -1, that's a -1, that's a -2. Remember, this has 2 polyatomics in it. It has ammonium and it has carbonate. But both of those are known, so you don't need to do anything. That will be ammonium carbonate all by itself. So that one's easy. You just name the 2. This one's easy. You just name the 2. When there's only one choice for the cation, you just name the 2, like those. The rest, you're going to have to calculate the charge. And I'll erase these notes here, and you can go through and practice these. I'll pause here for a second, and then I'll show you the answers. And with that, let's review. So if the cations have a number, that's the charge in the metal. That would, you have to write a positive when you write the charge, but that is the charge in Roman numerals. The anions will end in "ide" for all of the monoatomic ions. The exceptions are hydroxide and cyanide. Those are the only polyatomics that you are learning that end in "ide." All the rest end in "ite" or "ate." That tells you polyatomic. Anytime you see "ite" and "ate," you automatically know it's an ionic compound. So use ionic rules. If you see "ide" at the end, then you don't know. You have to look, is there a metal there? And the metal should be the first thing you look for, a metal or a cation. And the only cation you're going to look for in the beginning here is either a metal or ammonium. And that is a +1 charge. Those are your only cations. And if it has a metal or an ammonium, it's an ionic compound. Use ionic rules. And the "ite" and "ate" tells you it's a polyatomic right away, and it usually has oxygen in it. So here are some where you're given the name, and this is easier because you use the crisscross simplify. Ammonium chloride. Well, you would start it by writing ammonium, and I recommend you always put parentheses around it, and then chloride. You know chloride is -1. You know ammonium is +1. Crisscross, it's 1 of each, and you end up with 1 ammonium and 1 chloride. If you kept the parentheses around it when you didn't need a parentheses, it's not correct, but I will never mark it wrong. But if you have to have a parentheses there, and you didn't, for instance, if you said there were iron and hydroxide, and you said it was iron 3 hydroxide, that's -1. well, you need to crisscross here. You'd find that your formula is FeOH and 3 OHs. If you had written instead FeOH3, this means that there are 3 hydrogens. This means, the first one means there are 3 OHs. This would be correct. This would be wrong. So don't ever write it like that. You need a parentheses if there's more than one. You don't need a parentheses if there's only one, but if you wrote one in when it was unnecessary, that will be fine. So iron 2 perchlorate, we have iron 2, so let's write that, iron 2, and perchlorate, that is ClO4, parentheses, -1. Crisscross and simplify, 1 iron, 2 perchlorates. Go through these. I'm just going to jump around to one right here. Here's one right here. Oops. Number 8, lead 2 phosphite. So we know lead 2. We write that. And phosphite is PO3. And the whole thing has a -2 charge. I'm sorry, a -3 charge, my bad. -3 charge. 3 goes there, 2 goes here, and we would write lead Pb3 PO3, keep the parentheses there because we have 2 of them, and that would be your answer, your final answer. So I'll leave these to you to practice. I'll pause here. If you don't see a parentheses around the polyatomic, it's because there was only one of them. And with that, we'll stop here.